Good morning. Welcome, broadband professionals. For those of you that don't know me, I'm Woody Cash, SCT Content Knowledge Officer. And today we'll be presenting Fiber to the Home and PON service activation and troubleshooting. Fiber to the Home and PON is quickly becoming the preferred network for both greenfield and business park deployments. Today's presenter is Stephen Colangelo. He is a domain sales expert at Viavi Solutions, focusing on fiber and metro solutions for the CATV MSO market. Stephen leverages 30 plus years of experience providing test and measurement solutions to service providers, MSOs, utility companies, and contractors. Stephen's background includes various engineering, marketing, and business deployment roles. Before we get started, I'd like to cover a few benefits of the SCTE. For those of you that are members, please take advantage of our website. There's just a plethora of training on that website that involves everything from courses that you can take to micro lessons, lightning mods. If you only have a couple of minutes, we also have like primers that or less than 2 minutes that give you like information on specific topics. It's a great place where you can help develop your own skills and knowledge. I would also like to add, we have Golden Gate chapter has a YouTube channel, so please check it out when you have a chance. We have a few past webinars up there. We also have interviews from our Broadband Founders Club inductees. So you want to know a little bit of history about our industry, check those out. Also, if you want to get to know your board of directors, we have episodes of our board of directors being interviewed. Typically post about one a month, so try to keep those going. And as far as board news, we have completed our elections. So we are currently onboarding new board of directors. They're in the onboarding process. Sorry to repeat myself, but we will be making an announcement and introducing our new board of directors in January. So to finish out the year, we have a couple of webinars. One is our next one will be 11.4 Powering Critical Infrastructure by Intersys. And then we have our December Fall Training Summit. And that will begin December 2nd. It's 2 weeks long. So we will have training every day for 2 weeks, starting on 12/2. And that will be Tuesday through Thursday. So if you get a chance, look into your feed and you will start seeing those. I saw some in there this morning. So those are coming in, and we'll get those all up to date so they'll all be there in the next week or so. So with that, I'm going to turn it over to Stephen. And by the way, if you have questions, just type them in the chat. And then Stephen is going to pause periodically, and then I'll try to read those out. And I don't know about the rest of you, but my camera keeps freezing. So I'm definitely going to go off camera and may not use it if that continues to happen. First time using this platform. So if you would mind, please be patient while we stumble through. Thank you, everyone. And Stephen, I just want to say thank you for taking the time to do this webinar. I know I learn a lot from your trainings, and I'm sure our audience does the same.
All right, great. Thanks for the intro, Woody. Morning, everyone. And I will likely do the same thing as Woody. I'll be on camera right now, but as we switch over to the presentation, I will shut that off. And like Woody said, enter your questions in the chat and we'll stop periodically. All right, so hopefully that looks okay. All right. So today's webinar, obviously, fiber to the home and PON, service activation and troubleshooting. So kind of the agenda that we'll lay out here, and I'm just going to use the highlighter. So really four main objectives. So we'll kind of start out with the PON architecture and components to give everybody kind of the background and the basis of, what it takes to put one of these systems together. And then, as with most things, in order to make the deployment worthwhile and easy to deploy, there's standards associated with this. And then we'll get into the deployment phases and lessons, best practices and lessons learned from some of the large PON installs that Viavi's been part of over the last 10 plus years. And then, of course, the tools that it'll take to be successful. So quick technology intro. So when we talk about PON stands for Passive Optical Networks, but there's a few things that are very different about those versus the traditional point-to-point type networks. So the first of which, as the name states, is it's purely passive. So that's great from the standpoint of, you don't have any outside amplifiers, any things to power, anything to balance. So it becomes a lot easier from that standpoint. The value lies into the point to multi-point architecture. So you use a common fiber that feeds a splitter, and then there's various splitter counts and architectures that allow you to get multiple users. Typically 32 users per fiber or per OLT card is typical, but it can be higher than that. And then in order to keep the services and different types of rates in check, there's different wavelengths or frequencies that are used. And kind of the way a lot of these work is that the downstream is transmitted to all the ONTs or ONUs, depending on the technology, they use the different references, but basically it's the same device. Those coming from the traditional cable side of things, this would be known as your CPE, customer premise equipment, but basically it's some type of box that's in the house, and that does the filtering. And then, depending on the PON type or architecture, can be TDMA. And the splitters are really kind of the star of the show as to what's different here. They're great because they do provide that ability to go from a point to multi-point. But just one thing to keep in mind is that because of those multiple splits, it can use a large portion of the optical budget. So I think everybody is used to, if you split something in half, a 1x2 splitter, it's about a 3 dB loss. When you get into, like I said, that typical 1x32, it's 16 plus dB a loss. So you have a very high loss component. And what that would look like in the simplest form is the single split. So basically you have a single fiber going to an optical splitter, and then that splits out into drop terminals, and also known as a tap in the cable world. And then from that drop terminal or tap to the home. So that's the simple single split architecture. A lot of times what you'll run into is a cascaded split. So just depending on the layout of the homes, or if it's an MDU, you'll have that single fiber to the first splitter, but then you'll have cascaded splitters down the line. Again, that just help with the distribution, based on the footprint that you need to cover. And then more recently, there's a third architecture that's kind of come into play that's known as an unbalanced split. And typically this provides a little bit longer reach. And what it does in addition to the splitters is it uses some form of tap. And a lot of times these are kind of all in one device, where you'll have, in this case, it's a little bit hard to read, but you'll have like a 90-10 where 90% of the signal will pass through. You'll tap 10% of that signal off, and then run that through a 1x8 splitter to a group of homes, and then that 90% continues into the next 90-10. And as you keep going through this architecture, you'll have to tap more power because it's been reduced to feed the splitter. And in this case, we get down towards the end here, and now it's a 60-40 feeding that 1x8. But this has been, kind of a new architecture. It's a little bit more complex, but it gives you an additional deployment method, just depending on, like I said, how closely things are spaced, or in this case, what type of distances or density you need to cover. So in addition to the different architectures, there's different wavelengths or frequencies that have been identified. So for the EPON and GPON technologies, this is the lower rate up to probably 2.5 gig or so. 1490 downstream and 1310 upstream are the wavelengths that have been identified by the standards. And then when you get into the higher 10 gig variants of XGS-PON or 10 gig EPON, it's 1577 downstream and 1270 upstream. And then there's another variant that's not real commonly used, but NG-PON2 allows you to basically WDM up to 8 channels at 10 gigabits each. And here's the wavelength ranges identified for those. And then your traditional RF video overlay or RFOG, if you still have that, is 1550 down, 1610 up. So that's kind of what's been in play, for the last 20 years or so. And then within the last year or two, things like 25 gig and 50 gig have also started to emerge. So for 25 gig PON, it's 1358 downstream, but then you have a choice of one of 3 different wavelengths for the upstream just based on what else is already deployed in your network. So you'll see like 1270 is designated to be compatible with XGS-PON, 1300 would be with GPON, and then 1286 would be for other variants. So it does give you some flexibility when you get into these 25 gig, and then 50 gig is very similar. Your downstream is somewhere around 1340, and then there's 3 different choices for the upstream, again, based on what else is in that network. And last but not least is when they defined the standard, they also knew that testing had to be something that was done live and in service, so it had to be out of band. So they identified an in-service OTDR testing window between 1625 and 1675, with 1650 being most prevalent. So when you look at all those kind of laid together on a wavelength line, this is what they would look like. So basically the idea is that any of these technologies would be able to coexist on that same fiber. You might see a little bit of overlap when you get into the 25 gig and 50 gig, but that's why they gave you 3 different options for the upstream. So nice thing with this is if you've already got GPON or EPON deployed and now you want to add the 10 gig variant, it's just a different window that's not in use. And even as you start to go towards 25 and 50 gig PON, that can be added on that same fiber without interference. So again, it allows you to really take advantage of that fiber, but also deliver multiple classes of service just based on your customer base. Residential for the lower rate, small to medium business, and then when you start getting into 25 and 50, high density cell towers, MDUs, and even larger businesses. And here I mentioned the standards earlier. So there's 2 main standards bodies that govern this. So the first of which is the ITU, and that's what you can see in blue. There's a couple different standards that have evolved since 2003, basically just adding more capacity. So it started out you were at about 1.2 upstream and downstream, and then that bumped to 2.4, and then 10 gigabit standards came out, and then the ability to couple multiple with that NG-PON2, and then the 25 gig and 50 gig. And then very similar for the IEEE, which typically has been more widely deployed by the MSOs because it's Ethernet based. It was just an easier deployment. So very similar there. You had a 1.25 up and down. You had a 10 gig symmetrical. And then at 25, you can have 25 down and 10 up or symmetrical. And similar for 50. You can have 50 down and then 10, 25, or 50 up. And then you'll see by the standards what's defined as the maximum split ratios, the maximum distance and loss, and then, of course, the fiber types that support these. Basically, it just needs to be some type of all-wave fiber based on that spectrum that we saw earlier, so it doesn't have a water peak or any potential issues like that. So when you put all these things together, this is what a typical PON network topology would look like. So in the central office or in the head end, you would have the different line cards, also known as OLTs. And then there's some type of coexistence element that couples all of those together to be able to feed that down a common fiber over the optical distribution network. And then in this case, we're just doing the single 1 by whatever optical split, and then feeding basically really any number of services, from your residential to a business park to mobile backhaul, even data centers. You get into the higher, and then any other businesses or campuses, private entities that you see. So the individual elements that make this up, so obviously the OLT, optical line terminal, that's the line card that's in your head end or hub potentially. And then there's the fiber distribution hub. So this really takes care of all your fiber management and connections. This is an outside plant piece, as is the optical splitter. In many cases, that splitter may be in that same distribution cabinet, or it may not. And then the typical taps, usually using some type of hardened connector. You can see that by the cabling here. And then last but not least is that CPE or ONU or ONT, just depending on the technology that's used. So that's a little bit of the technology background. I'll just pause quickly here and see if there's any questions that came in, Woody.
Sorry, couldn't find the mute button. So there is a question from Maurice. Maurice asks, are there any limitations to any type of PON being able to handle specific services such as VoIP?
What was the last part? Was it VoIP?
VoIP, yeah.
Not to my knowledge. That's one of the advantages with fiber, is that provides virtually unlimited bandwidth. So it's really just governed by the electronics on each end. And things like a VoIP service, whatever, as long as you can encapsulate that into whatever the technology is, should be no issues.
Yeah, and correct me if I'm wrong, but I believe when you set up VoIP service, you also prioritize that. So you don't.
Yes.
That gets priority bandwidth as long as it is, what can I say, part of your provider's package. I'm not sure about off brands anymore. There used to be some off brands that they weren't necessarily prioritized, but I think the network does recognize VoIP and does prioritize that. So no, there should be no issues when you're using fiber for VoIP that I'm aware of. Okay, I did have a question for the audience, and I noticed Stephen talked about XGS-PON. Is anybody out there aware of people deploying XGS-PON? Just for my curiosity. Oh, and I do have another question from Jung Ming. Is unbalanced split famous for other operators? It's kind of new to me. So he was asking a question about unbalanced split. I think I understand.
Yep. No, that's a great question, and it definitely is something that was much more widely deployed in Latin and South America. That's where we got all the experience with it. And then I would say within the last maybe 2 years is where we finally started seeing it in the U.S. And some of the major cable operators in the U.S. are starting to deploy that. So both cable and on the traditional service provider side of things. So it definitely was slow in coming to the U.S. Like I said, much more widely deployed in Latin America, but it is now in the U.S. and gaining a lot of popularity and traction.
And I'd just like to thank everybody for asking questions. Please keep those coming. We'll pause again and read them out. Thank you. That's all the questions for now, Stephen.
Okay. All right. So now we'll move into kind of the lessons fiber to the home since the early 2000s, and here's some of the things that we've seen. So this is a survey that was done by Light Reading, an SCTE in October 2020, 5 years ago, but nothing has changed. The only thing that's changed is the volumes of fiber to the home deployments. So this was what that survey found, and like I said, it's now It's the same percentages, it's just higher numbers and volumes. So depending on how you wanted to look at this, under 10% failure rate was about 50%. So, you may look at that as pretty good, but the other way you got to look at this is 50% also didn't pass the first time around. So, so obviously there were a lot of lessons learned here and things that you can do to kind of improve those numbers. And why that's important is things like this. So this is kind of what shaped a lot of that. Once we saw those numbers, we started looking into it, just looking at tens of thousands of records we've seen of fiber to home installs and trouble tickets and so on. And we saw and this is basically what it looked like. So kind of what this graph is showing is, the losses of that drop fiber versus the distance. And what we saw is the greatest concentration is really within the first 1,000 feet from the CPE device. So essentially that's, everything that's in the home, that's in most cases the drop cable going out to the tap as being the most vulnerable place. So we focused a lot on that. And, some of the things that we saw that were potential issues were low or marginal power at the CPE device, and then you put it into service. Even though it had a passing power level, it was close to the threshold. So obviously any variance took that, either out of service or affected the service. So that resulted in trouble calls. And then just, because this was new, a lot of these people that were doing the installs weren't real familiar with fiber. A lot of them were traditional RF techs, and there is a little bit different best practice that you need to work on for fiber or be concerned with. So things like, just the routing of the fiber, the dirty connectors and things like that. So these were things that, could easily be addressed during the initial build that improved the reliability. And then also, just like everything else, the system may have worked great when you initially turned it up with lower rate or lower grade services, but now as data rates and expectations, are approaching 10 gig and everything is streaming these days, what was initially put in play, just, you start to see the flaws of that. So taking all that into account, we kind of came up with this checklist of really 4 things that can really improve that initial quality build. So the first is inspection and cleaning. Anybody who's dealt with fiber has heard this 100 times, but it's still relevant and just as important as ever. The second is looking at the power. So we talked about how many different technologies and different wavelengths and different frequencies there were. So it's very important to not only get a power measurement, but make sure that you're reading the right light or the right service to verify that. And then, of course, the qualification of the drop fiber. Again, a lot of times this is built once a customer signs up, that piece from the tap to the home. So being able to look at a lot of that is, multiple pieces, multiple connections. You got a connection at the tap. Then you run a fiber probably to some box, some type of house box. You'll have a connector pair in there, and then from the house box into the house, and then to the CPE device. So several different connectors, a lot of fiber routing, and a lot of it's exposed. So that can greatly affect the installation. And then last but not least, once you have the service turned up, everybody these days uses Wi-Fi for just about everything. That's how they rate the service. So it's important for you to test the Wi-Fi capability, in different areas of the home and so on, to certify that and give them really the overall experience they're expecting. So if we break these down, the first segment would be the inspection and cleaning phase. And in a perfect world, this is what you should see. So this is your typical SC fiber. In some cases you can see the core, other times it's just the cladding. But ideally, this is what it should look like. The end face of that connector should be perfectly clean for the light to pass through it. The analogy I use here, this is like the headlights on your car. If the headlights on your car are contaminated, whether it's full of bugs from a summertime drive, or if you live in one of the winter climates, you get the salt buildup on the headlights and so on, it dims the lights. You clean the lights, they're bright again. Exact same thing happens with your optical connectors. Here's the typical types of contamination that you're going to see. It's either dust, dirt, lint, or so on, or some type of oil. The nice thing with these are just using a one-click or whatever type of cleaning tools you have. These can be proactively cleaned to get that simplex connector you see up above. The downside of that is if you had dirt or sand or something in there and it got ground into it, you start to get into the pits and chips and scratches. And by that point, the damage is already done. So really it's, either cut that connector off and replace it or replace that patch cord. And then the one example I'll also give is, if it is a patch cord or a connector, that's usually a few dollars. It's an easy fix, but it can also affect the transmission equipment. So this last example here was actually an EDFA that had oil on it. Turned the EDFA on, got up to plus 17 or whatever, and actually just burned the oil onto the EDFA and destroyed it. And that was about $5,000. So not something you typically see in fiber to the home, but just kind of an example I wanted to show of how this can really affect things that are a little bit more expensive in the network. So as far as the inspection and cleaning, first and foremost, you have to make sure you do both sides of the connector. I've seen people take a connector out, clean it, plug it back into where the other connector already was, and then take that connector out. And by that point, anything that was on that first connector already transferred back to your clean one, so you're just moving it back and forth. So you have to disconnect both, clean and inspect both, and then connect them. So that's the number one tool. So whether it's two connectors or it's a connector and a port, you got to do both sides before you plug in. And then the other thing that can be interesting is there's so many different types of connectors out in the field. In the field node example we have here, there's 3 different connector types. You've got your standard SCAPC, and then you've got a multi-fiber MPO connector, and then you've got some LCUPC. So you've got multiple connectors just in that device. The taps and drops, like I mentioned earlier, it's usually some type of hardened connector, OptiTap, Evolve, DLX. There's a bunch of these out there, but they typically require special inspection tips to be able to get into the ports. And even at the CPE device, you may have an SCUPC, you might have an SCAPC. So a lot of different connector types there to take into account. So the next thing we'll look at is the power measurement. And I added that wavelength range again across the top to just remember what we're dealing with here. So at a minimum, you have, even if you have one service, you have an upstream and a downstream wavelength. But like I said, in a lot of cases, you'll have an EPON plus a 10 gig EPON. So you'll have 2 wavelengths down, 2 wavelengths up. So it's important to be able to isolate and measure that. So we'll talk a little bit about the power meters that are available to do that. So the most basic is what we call a broadband power meter. And this essentially will read any light. So you can plug any fiber into it. It's going to give you a reading. It's always a great meter for light, no light. These are relatively low cost. But the only catch with these is that it gives you, if there's more than one wavelength present, it's just going to be the average power of all the wavelengths present. There's no way to filter out one specific wavelength. And these obviously are downstream only because you're just connecting to a splitter port or a tap port or a CPE port. And then just kind of one quick note, most of these broadband power meters, they do have the ability to do what they call select or set the wavelength, but all that does is change the calibration point. It does not isolate or filter. So it's not really going to change the value. It's not going to allow you to look at the individual service. So really, from the broadband power meter standpoint, it's answering the question, do I have light and what is the level? The next type would be what we call a selective or filtered PON power meter. And in this case, it's called a terminate because it's only looking at the downstream. But this has some type of filter in it that allows you to look at the 2 wavelengths. So in this example, it's GPON and XGS PON, or it's EPON and 10 gig EPON. They both use the same wavelengths. So this has the ability to isolate and measure each downstream. So now you can see what your lower rate service is versus your 10 gig service. So the question this is answering is, do I have the right power and the right wavelength or frequency present? And then the most advanced tool is a selective power meter with through mode. So this has basically 2 ports. You connect it in series, and this now completes the circuit. The CPE device transmits upstream, So now you have the ability to measure upstream and downstream simultaneously, and it's all filtered. So this gives you, this is probably the most deluxe scenario that you see here, but you're looking at your 1490 and 1310 GPON or EPON up and down, and then your 1577 and 1270 10 gig PON up and down. And then in this case, you still do have the RF video or RFOG overlay as well. So you can isolate each individually and see what signals are there. So this is kind of your most advanced troubleshooting. So what this is telling you is, do you have the right power and wavelength both in the upstream and downstream? So typically from a deployment standpoint, most technicians probably have one of the first two, and then the selective through mode would be kind of an escalation tool that the next level tech might have. But we've seen, all different deployments. So now we'll look at the actual fiber and troubleshooting. So in this case, there's tools out there that are typically referred to as something like a drop cable service activation meter or something like that. And these combine a couple tools into one. So in this case, it's a fault locator, but it has that terminate selective PON power meter, and it does it over having a single connection. So the idea is you sign up a customer, you build out the drop cable. Now you use this type of tool and be able to verify that you're receiving the right frequency, the right power level, and then also a quick fault locator shot or OTDR shot to verify all the fiber routing, all the splices, all the connectors. And this is done, very importantly, this is done with a filtered 1650 OTDR. So basically the filter blocks any of the live transmissions coming down, so it doesn't affect the OTDR. But then when you launch the test at 1650, it rides above all the traffic and doesn't interfere. So this is how you handle or manage a live PON network. And of course, there's other tools like launch cable and VFL. You can add the microscope, and basically you're using this to verify the power levels, the wavelengths, the drop cable installation, the routing, connectors, and do that all well without disrupting the service. So this is just an example of what our screen looks like. It's showing you the test direction of the ONT towards the splitter. So basically in the house shooting back to the splitter. There's your light level verification for each of the wavelengths individually, and then the fault link mapping that shows you the footages and whether each connector is good or bad, and whether you have connectivity to the splitter. So the whole goal here is to verify the installation the first time around. So this is kind of your birth certificate. If everything's built right and passes, there should be no reason for callbacks or for escalation for a maintenance crew. So the use cases for this, obviously the first one would be for the service activation and turn up. So basically, again, the idea is to document the installation, make sure you have good power for all your services, and then also to verify that fiber routing. So in this case, there's a launch cable, then at 0 feet, that's essentially your CPE connection. Everything's green and good. 15 feet away from that, you probably have something like a box on the side of the house or a wall plate. Then you go another 25 feet. So 40 feet into the system, you have probably the box on the side of the house, and then another 90 feet to the splitter. So in this case, it's about 130 feet overall. Everything looks good except for this one, number 5, has the red X. And then when you tap on that, it'll show you, specifically what the issue would be. So overall pass fail, good power at each of the frequencies, looking for any failing events, and then your total link loss, length, number of events, and basically documentation. Everything passes here, there's your certification. So when we look at the troubleshooting examples like that previous one, anything that would have been highlighted. So in this case, we're tapping on this event at 865 feet, and basically it's showing a 1.94 dB loss, which is very high for a connector. So tells you exactly where to go. So we go right to that particular connection, at 865 feet. Pull out our fiber scope, and we have a very dirty, oily connector. We clean it using whatever. Now it's nice and clean. And that 1.94 connector after the cleaning is now down to a 0.24. So the nice thing with this tool is, you were failing, your power was getting marginal. This told you exactly why. At 865 feet, I go out there, I had a dirty connector, I cleaned it, I gained, about a dB and a half. Now my overall power is down around 22, minus 22. Gives me a lot more overhead, a lot more reliable service to that customer. And similarly, here's an example with just the fiber routing. So same type of thing. We have an event here that's showing red at 0 feet. So this is showing us right at the test location. And these are just a couple examples we've seen in the field. One of these is kind of an enclosure, and it might be hard to see, but there's this figure S curve here that's causing a lot of loss. And we've seen the same thing with a box on the side of the house. So this one in the upper right-hand corner, the first thing you see is the cable comes in, goes to the upper right-hand corner, and it's almost a 270-degree bend there. And then you've got a really sharp bend coming into the fiber and out of the fiber. So really, in this case, they just didn't leave enough slack. If they brought this in and looped it around, this would have been a lot cleaner and a lot less issues. But simple things like that, drop the loss significantly just by changing the fiber routing. So in this case, it was about a 1.8 dB loss. And after they repaired that, they got it down to less than half a dB for the connector plus all the routing. So again, another 1+ dB gain just by the fiber routing. So in this case, this was from a trouble call. But like I said, if they just put a little bit more cable slack in here, rerouted these a little bit different, would have been no issues. And then one of the things that we've seen is field splice-on connectors. There's two different ways to deploy the drop. One of which would be using preterm cable. The other which would be splice-on connectors. And splice-on connectors, we've seen sometimes they just don't work as well as they should. We've seen issues with just not rotating cleaver blades, the cleavers weren't clean and so on. So when they put the connectors on, it wasn't as good. But again, this immediately identifies which connector or which connectors have issues, right where to go, and quickly resolve that problem. And then, of course, there's the scenario of something like this where, it was broken underground. So whether this was somebody putting in a fence post, a mailbox, a weed eater, whatever, tells you exactly where that footage is and where to go to resolve it. So here's an aerial example, 200 feet, whether it's a squirrel chew, a branch falling on it, or whatever. But again, it tells you exactly why you don't have connectivity. In this case, shooting from the house, but you could shoot from the tap or anywhere as well. But again, knowing exactly where to go is going to eliminate a lot of the time and guesswork. And then last but not least is the visual fault locator. So kind of the red light tool. These are nice because they show, you can use them for continuity. You shine the red light in, you get the red light out the other side. So you know that you've identified exactly which fiber you should be on, that you have continuity. But it can also identify breaks. In this case, it's just a yellow jacketed jumper. In this case, it was broken and you can see a red glow. So you know that that's broken and that cable needs to be replaced. Then, of course, the last section that we talked about is the actual multi-gig throughput verification. So, up to 1 gig, customers want their service to work. They expect it to work. But when you start getting into the 2.5, the 5 gig, and the 10 gig tiers, they really like to see documentation that they're getting what they provide. So we just refer to this as multi-gig. So what we're talking about here is, different types of tests. So obviously it's all optical up to that CPE device in the house. So basically, you want to verify right coming into that CPE device. Do I have light? Is it the right light and the right level? And then once you plug in that CPE device, now you're looking at things like delivering the Ethernet speeds. So if it's a 1 gig service, coming out of that Ethernet port, you should see probably somewhere around 940 meg just because of the overhead. And there's different ways to test this, whether it's Ookla, speed test, speed check, and so on. But that's one of the things that customers really like to see is, okay, I'm delivering, near 1 gig or over 1 gig. I think a lot of service providers, they over provision. They provide like 1.1 or 1.2 gigs so that when you get to this Ethernet port, you are seeing truly over 1 gig, which is the customer expectation. And then you just keep stepping through that. Like I mentioned, Wi-Fi being the most common way that everybody measures their performance and how happy they are with the service. So now you start looking at the Wi-Fi speeds, the Wi-Fi coverage, and if there's ways that you can improve that. So this is, kind of really the customer perspective. And again, what you're looking at here is by verifying these things during the initial installation, it's going to improve the customer satisfaction and eliminate callbacks and issues. And it's very similar to, on the DOCSIS side of things. You may have both. And this is one of the things and one of the requests that we've had at Viavi is, I don't want to carry multiple meters. I still have a ton of DOCSIS out there, but now I also have fiber to the home. It's the same techs. He's doing 2 DOCSIS jobs today and 1 fiber job. Is there a tool that does both? And the answer is yes. So basically you're certifying the same types of things that you always did in the DOCSIS network. And then on the fiber, you're dealing with everything that we talked about. And then once you get on the other side of that modem or that CPE device, now it's all Ethernet and Wi-Fi. So having a tool that can handle both obviously is very useful. And here's just kind of the traditional checks. And then last but not least is the coverage. So a lot of this has to do with the positioning of the Wi-Fi router. So being able to look at that and map it out. In this case, the router's way back here. So anything that's close to that, has good service. But as you start getting into more of the remote areas, the office up here, the game room and so on, maybe moving that router to the middle of the house or put some type of repeater or extender would help provide better service throughout that house and again improve that customer experience. So just by being able to do some type of Wi-Fi mapping, again helps with that. And then tying it all together, here's the types of tools. This is obviously the Viavi portfolio, but most of the vendors out here have something similar. So you go anywhere from those basic point-to-point filtered power meters to that drop cable installation tool that has not only the power meter, but then the link certification and the VFL for troubleshooting, or a multi-gig tool. In our case, it's the NSC, so that can do all your Wi-Fi and testing up to 10 gig. And then our newest, the ONX 7 series, basically does all of that, does all the traditional DOCSIS plus the selective power meter, up to 10 gigabit service verification, Wi-Fi, VFL, and so on. And this is what our tools would look like. So inspection, a bunch of different scopes, either standalone or USB that can add it to any other meter. Handheld meters, Optimeter is kind of that drop cable tool. There's the network service multi-gig test tool, and then the all-in-one. And last but not least is just ways to automate the testing and results. So for us, we have cloud-based solutions that can be used for a number of things, such as asset management, but you can also start to use that to deploy testing criteria and templates, push that through. Basically, everybody's got a phone these days, so you can use what we call the mobile tech app, and that acts as the intermediate to any of the field instruments. So basically, you can just Wi-Fi or Bluetooth connect to your phone and then immediately upload results, or immediately get results on your phone and be able to show the customer, here's the certification of the 5 gig service. And then just depending on how far you wanted to go with that, you can warehouse the data, you can start to run analytics on it, and so on. So different ways to integrate this, just to see that you're deploying most efficiently or identify trends that might be causing issues. And with that, we will end the presentation, and I will open it back up for questions. So a lot of information, but hopefully it made sense in the way I tried to lay it out.
I'm not seeing any more questions, Stephen, but I'd just like to ask the audience, do you have any more questions? Now would be the good time to ask. And I have a question, Stephen.
Okay.
So I know you showed the survey about success of installations. Is there any breakdown of that, of what reasons, like almost 50% or more than 50% of the new installations are not functioning right the first time?
Yeah, there's a couple different breakdowns, and I'm trying to get back to that slide without taking too long here, but a lot of it, did tie into either craftsmanship issues or just being new to fiber. So that's why we kind of came up with this 4-step process. These were the 4 corrective actions, I guess, for lack of a better term. But they didn't have the information, but it was, I think if I go back to the screen, it was things like, the inspection and cleaning piece of it was still a high majority of it. Like I said, especially people come from the RF world that weren't used to dealing with optics. It was just simple things like, just taking something brand new out of the bag and plugging it in without cleaning it or inspecting it. The expectation is, obviously it's brand new, it's out of the bag, the caps are on it. But what happens, patch codes are a good example. They have these little plastic dust caps on them, and those dust caps, just like the dashboard in your car, as they age, they start to release the oils, and that oil builds up on the connector face. So, just something simple as, even though it's brand new, take it out and inspect it. And if there's oil on it, clean it. That improved the reliability of the network. And then just, the whole power measurement thing, being able to look at the fiber routing, just like some of the examples I showed where things were wrapped very, very tightly, very sharp bends. Even though a lot of these are bend insensitive fibers, it still doesn't mean that you can take them and like wrap them around a pencil or a pen. They still do have bend radiuses, of the size of like a soda or beer can. So you want to keep that in mind. So that, again, that's kind of an installation issue. And then really just the craftsmanship of putting on the splice on connectors or things like that and the routing. And then just the overall, kind of Wi-Fi and router placement and so on. So it's, there's no one answer, but I think in a lot of ways, these corrective actions kind of identified the majority of what those issues were.
I guess the age-old adage that don't expect what you don't inspect is very true. So you should never assume, even though it was in service, that a fiber interface is actually clean. Even if you pulled it off, it was already being used. It may not be clean. It may not work right when you plug it back in because you've changed the alignment slightly. And if that part of the connector is got some dirt on it, then all of a sudden now it's losing a lot of signal. Yeah, and it was fine before, so you assume it's fine because it was working, but now you've moved it and it may not be fine. So it looks like more than anything, it's just the tools and training is just a big part of this, right? And then obviously connector cleaning, because connectors tend to be like the #1 point of failure, even in the light world. I know it is in the RF world, but even in the light world, it seems to be like the most common point of failure.
Yep, absolutely. And that's where this, I'm trying to highlight like the link certification here. A lot of these early installs were just done with power meters. So it's like, well, I got good light, it's good enough. But what you didn't know in that was, that you had all these bad connectors that either weren't snapped in or you had all these fiber routing issues. Without some type of fiber link map like this, you just don't know what you don't know. And, just being able to finally see this was kind of like a light bulb for it's like, okay, the service might work, but for how long? But if I have the certification where I've tested every connector, all the routing and everything all the way back to the splitter, now I know the integrity is going to be there.
So if you test a strand with an OTDR, is there any value to going to the customer end and checking the power level?
Typically, this test is typically done from in the house. You can also do it from, the
Okay.
tap or anything external. But the advantage of doing it from the CPE is now when you're measuring the light level and taking the OTDR shot, you're seeing exactly what the CPE is.
So I hope things have changed, but I do remember that contractors would be testing from the transmitter point, testing with the OTDR to see when they install the fiber that, that this was pre-installation,
Mhm.
that everything was working. And my thought was, yeah, but do you even know that strand is going to the exact right location where the customer CPE is going to be? Or is it, is
Yeah.
it taking a turn and you didn't realize it, or at the last 100 meters you spliced in a fiber that went to a different room or something?
Yeah.
So
Yep.
I was thinking if you do that, if you have a contractor testing from, say, the head end, you definitely want somebody to be at the other end to say, okay, yeah, I see the light, toggle the light on and off. I see it here. If your test is good, then everything should be okay.
Yep, absolutely. And one of the examples that we've seen is when you get into higher density things, like an MDU is a good example where you have, some type of equipment room in the basement and then multiple splitters on, each floor. We've seen fibers get crossed, so there's issues with routing like that when services don't turn up. So, that's where things like, being able to test right from the unit back verifies the pathway. Things like the red light can trace it. And then there's even, something I didn't really cover too much, but there's something called PON ID that actually reads the PON protocol and tells you which OLT line card you're connected to.
Oh,
So that
that's
so
very
that helps,
nice.
with the deployment as well, or with
Oh,
troubleshooting if it doesn't work.
yeah. So for everybody, so that we can get that percentage of success. Uh, yeah, you're probably not going to overtrain yourself in the optical world, and also definitely want the tools and equipment to get everything installed correctly. So actually, pre-install testing is just awesome if you could do that. Not everybody does, but it's very helpful if you can do that. And again, having the right training and the tools for the job is just imperative. And I do not see any more questions. I've think I've asked everything I have. So I think Stephen, just like to take a minute to thank you for presenting, and thank the audience for joining today. And I'll go ahead and end the stream. What's a question about recording? Yes, the session will be recorded, and typically it'll be available about 30 minutes after the conclusion. However, I just sent in the speaker release form yesterday, so unless that's been processed, it might take a little longer. So just check back periodically, and I think you will see the recording, and I think it'll post on the same platform, so you won't have to go looking for it, or at least not too far. So thank you for bearing with us. First time on this platform, seemed to work okay. So looking forward to doing more presentations here. Thank you, everybody, and have a wonderful day.
Thanks, everyone.